Hello, everyone, and a very warm welcome to Mydbops MyWebinar 52. This is Shiny from Mydbops, your host for today's session. Today, we are exploring latest in MySQL, which is MySQL 9.7, and we are focusing closely on two major features, JSON Duality Views and Hypergraph Optimizer. So we have structured this session into two key segments. In the first half, we'll explain about JSON Duality Views, and in the second half, we'll focus on the Hypergraph Optimizer. So this webinar is being recorded. We will also be running a dedicated Q&A session at the end of the presentation. So please feel free to drop your questions into the chat box at any point during the talk. And before we get started, we are proud to announce a major milestone. Mydbops has officially completed over 10 years of scaling databases. Today, our team supports more than 800 clients, and we deliver tailored database consulting and 24/7 managed support across MySQL, MariaDB, MongoDB, Postgres, TiDB, AWS, Cassandra. So, to lead today's webinar, I'm happy to introduce our speaker, Shahbaz from Mydbops. Shahbaz is a key engineering voice here at Mydbops, highly regarded for his hands-on experience in solving complex database problems, and he's incredibly passionate about sharing knowledge. He has put together some excellent practical demonstrations for us today. So we are very glad to have you with us today, Shahbaz. Please take it away.
Hey Shiny, thanks for setting up the context. Hello everyone, welcome once again to the MyDBOps 50-second webinar. I am Shahbaz Gavasekar and I lead core data engineering team for MySQL at MyDBOps. Today we are going to cover two major additions in MySQL 9.7. One is JSON Duality Views, which lets you read and write the same data as in relational table as well as JSON documents. And the another is Hypergraph Optimizer, which is a smart query planner. So here's the agenda of what we will be going through in JSON Duality Views in MySQL 9.7. So starting from relational versus document model, what are the JSON Duality Views? How is concurrency control taken care with the help of E-tag in JSON Duality Views? What were the challenges we faced before MySQL 9.7 and how JSON Duality Views help us to solve the problems? Test cases, these are basically CRUD operations which are being performed using JSON Duality Views. Inspecting JSON Duality Views with the help of information schema in MySQL. And finally coming to the limitations and considerations. Now let's begin with understanding two data model that form the foundation of this feature, which is JSON Duality View. One is relational model, the other one is document model. In relational model, the data is stored in normalized structure. Referential integrity is enforced and querying nested data needs multi-table join. Whereas in document model, the data is stored in hierarchical structure. As the data is stored in one single document, you can read it in one query and there are no need of joins. Also, there is no built-in referential checks. So, JSON Duality Views help us to bridge the gaps between relational model and document model. Now let us see what JSON Duality Views actually are. JSON Duality Views are a new kind of views in MySQL 9.7 through which you can store the data in relational format and extract the data as a JSON document. You can read it as a document, you can write it as a document, and MySQL will take care of mapping everything to the underlying rows automatically. Here if you see, you have only one copy of the data, you don't have any data duplication. Also along with this, the JSON Duality Views are readable as well as writable. And one more thing which is important to note here is constraints are enforced. Now let us see what were the challenges we faced before MySQL 9.7. Challenge number one was JSON assembled in app code. What this means is developer had to write additional code to assemble the data, basically JSON data, in the application layer. The second challenge which we faced was JSON views were read-only. Prior to MySQL 9.7, there were no writable JSON views. JSON views were read-only. And the third challenge which we faced was same data, two copies. That means in couple of cases, a JSON copy was stored next to the real columns, which made the data duplication. Also, another important thing to note here is we had to keep this data in sync. Now let us see how JSON Duality Views helps us to solve the problems which existed before MySQL 9.7. No more app layer assembly. What this means is now there is no need for the developer to write the additional code. You just run the get the JSON data directly from the view. Number two, JSON Duality Views are fully writable now. Earlier we had only readable views. Now the views are fully writable, through which you can perform the CRUD operations. And number three, which is most important, single source of truth. Your data is only stored in the normalized table and the JSON view can be generated on demand. So there is no data duplication, data drift, or there is no need to maintain the data in sync. Another important thing which we are covering here is how is concurrency and transaction control taken care with the help of E-tag in JSON Duality Views. So before we dive into details, let me just tell you what E-tag is. E-tag is nothing but it's just a hash which represents the current row state. So whenever you give a read from the duality view, you get a E-tag along with it. So let me explain you how concurrency protection is taken care with the help of E-tag with one of the example. So if you see, we have two clients here, client A and client B. So both clients read the data from the view. So whenever both the clients read the data from the view, they get a E-tag along with it. So whenever they read, the E-tag which they get, it's A1, B2, C3. This is the E-tag which client A and client B gets when they read the data. Now client A updates the row or updates the data, and when it updates the data, it has to pass the latest E-tag along with it. So the E-tag which client A fetched is A1, B2, C3, and it passes this E-tag when it tries to update the data. So what MySQL does is MySQL checks this E-tag and it compares. Yes, if this is the latest E-tag, client A can update the data and finally the commit happens. Now, at the same time, client B also tries to update the same data within around same time. But when you see, the E-tag is already updated now. So whenever you do any writes or whenever you update the data, along with that, the E-tag also gets updated. But if you see, when client B is updating the data, it is passing the stale E-tag. The stale E-tag in the sense, it has passed the old E-tag. That is A1, B2, C3. So when client B tries to update the data again, passing stale data, that is A1, B2, C3, the update gets rejected and MySQL doesn't allow this to commit. This is how the E-tag helps in concurrency protection in JSON Duality Views. We are going to perform practical demonstration using the E-tag in the upcoming slides. So that's all was the theoretical part. Now let us come to some test cases. Basically, we are going to perform CRUD operations on this JSON Duality Views. So these are the underlying tables which we are going to refer. First table is department and the second table is employee. So in the employee, we have foreign key, which is referring to the primary key of the department table, that is ID. ID is the primary key of the department and department ID is the foreign key of the employee table, which is referring to the department table. So these are the two tables which we will be referring. Now test case 1. We are creating read-only JSON Duality View. So when we create read-only JSON Duality View, one important keyword to note here is JSON Relational Duality View. This is the keyword which is used to create the JSON Duality View. If you see, this keyword is used along with the name, that is department_row. So department_row is basically nothing but the name of the read-only JSON Duality Views. Along with this, you see one more keyword which is being present, JSON Duality Object. This is in the key value pairs. So every key maps to the actual column of the table. So now if you see keys underscore ID, which is mapped with the ID column of the department table. This is how the mapping takes place using JSON duality object keyword. No, so that was about creating the read-only JSON duality view. Now let us try creating a writable view. The writable view is nothing, it's similar to read-only view only, but it comes with the write permissions. Write permissions in the sense it comes with a clause with insert, update, delete at each nesting level. Each nesting level in the sense it comes with this clause at root level, that means at parent level, as well as with child level. So if you see, we have this clause present at two places. In case if you miss this clause at one of the place, that part of the view goes into read-only state, and then you won't be able to perform any writes for that specific table. But if you have this clause for root as well as child table, you will be able to perform these operations on both the tables through view. Now let us come to the third test case where we insert the data using JSON duality view. So if you see, the view which is created as a writable view is department underscore DB. So we are going to refer this view now, because the other view which is created is department underscore RO, which is basically a read-only view. So with this view, you can only fetch the data, you cannot write anything. But with department underscore DB, you will be able to perform writes because this is writable view. Now we are testing a test case. We are inserting a data, insert into department underscore DB, which is basically a writable view. We are inserting the values ID 10 department engineering followed by the employees. We are adding the 3 employees. Okay. Now when you insert the data through writable view, you see the 4 records are affected. Warnings 0. So let us see what are the records inserted now. So when MySQL parses the JSON document, which is inserted via the duality view, you can see that data is inserted in both the tables in one statement. The data is inserted in department table as well, and the data is inserted in employee table as well. One record gets inserted into department and 3 records get inserted into employee. That is why you see 4 rows affected. That means we are able to insert the data through writable view in both the tables. And from the backend, you can fetch the data and you validate it. You get the data inserted in department table as well as you get the data inserted in employee table. This was the case for the insert. Now let us see if we are able to read back the same data from the read-only view which is created. So when we read this data, we get it into the JSON document format. So we are reading it from read-only view department underscore RO, and we see we get the data, that is ID. Important thing to note here is, which we covered in our previous slide, it comes with an E tag. So you get an E tag also when you read this view. And finally, all the data. This is data from the department as well as the employee table. Now let us come to the next test case, that is updating the data via JSON duality view. Now we are updating again the writable view, which is department underscore DB, where we are changing the department to engineering underscore new. Earlier the department was engineering. Now we are changing this to engineering underscore new. At the same time, adding one more data, we are inserting a record to the employees table. The data, if you see, we have 3 rows in employees table. Now when updating the data, we are inserting one more rows. That is, if you see, this is Karan Mehta, which is the new one which is being inserted. Now when we perform the update, we give the condition that underscore ID as a 10. Okay. So when you see our view, the underscore ID is mapped to the, this is the view. Okay. So if you see, the underscore ID is mapped to the department.id column. Okay. So basically we are updating the department.id column. Now when you update the writable view, you see 2 records getting affected with 1 warning. 2 records are already expected because we are updating the department to engineering new, and we are inserting the new records in the employees table. but we did not expect any warning to come. Now let us see what is the warning we get. Yes, coming to the warning, E tag missing for the updated value. Yes, this is what we saw in our previous slides. So if you see, we updated the data, but we did not pass the E tag along with it. So that is why we have received this warning. But if you still see, the records are updated and the additional record is inserted. Even though we get a warning, the data will be inserted and data will be updated, but it will come with just a warning because the E tag is not passed. Now what we will do is we are going to fetch the latest E tag, and then let's see passing the E tag along with the update. And probably what we expect here is no warnings. So we are fetching the latest E tag from the view, and the E tag which we fetched is this. Okay. Now in the next update, probably this update, we are passing the E tag along with the update. In this update, if you see, we are not changing anything, but only change we are doing is we are changing the name of the department to engineering-platform. So when you update this using writable view, we see one row affected, which is expected, along with 0 warnings. That means this time we have passed E tag also along with update. That is the reason we have not received any warning. Now let us see if the data is affected. Yes. When you see the data from the department, the update is performed. We have the data as an engineering platform now. So as I told you in the previous slide, when we update the data, the E tag also is updated. So as we updated the data here, if you see, this was the previous E tag. And now if you see the latest E tag, it is the updated one. So this is the latest E tag which we get after the update is being performed. Now let us see the another test case where we pass the stale E tag in the upcoming update. So again, we are updating the data. Basically here we are changing the department from engineering platform to engineering stale with passing a stale E tag. This is the stale E tag because the latest E tag which we fetched is this. Okay, so if you see in the update, we are not passing the latest E tag, but we are passing some stale E tag. And when you see, if you pass the stale E tag and update the data, the update is rejected by the MySQL. And when you see the error, the E tag of the document in the database did not match with the E tag which we have passed in. Basically, what it tells is you have passed the E tag which is not matching with the E tag which is present in the document of the database. That is the reason MySQL has rejected this comment. Now again, let us try the same scenario where we pass the latest E tag. So this is the latest E tag which we already fetched. We are doing the same operation just by passing the latest E tag. So if you see, we have passed the latest E tag now. We see one row affected with 0 warnings. This is how the MySQL accepts the commit because the E tag is matched with the E tag of the document database. Now, if you see, the department table now reflects the update which we have done. Now, let me take you to the summary of the E tag flow. Basically, we have covered 4 things here. In the first update, we passed without E tag. The update succeeds with the warning. In the second case, we have passed the current E tag, update succeeds, 0 warnings, and basically then it returns a new E tag. In the third case, we have updated the row using stale E tag. And as expected, the update is rejected by the MySQL and the commit fails. In the fourth case, again, what we do is we update the data by passing the latest E tag and the update succeeds. This is how the concurrency is protected with the help of E tag in JSON Duality Views. Now let us test the final case, which is performing the deletes via JSON Duality View. So before deleting, let us confirm the rows in both the tables from the backend. So we have the 2 tables. One is department, which was recently updated as engineering-stale. There is another table which is employee. So both the tables has the data. Again, we are confirming the data just querying the department_db view. Yes, you can get the data in the document format. Still, this is giving us the data. If you see again here, you get an E tag. Okay, this is probably the latest E tag again. So now finally, when you perform the delete on this writable JSON dual, which is department underscore DV, where hyphen ID equal to 10. This is again, as you remember, this is mapped with the ID column of the department, the actual column. So when you perform this delete, you see the data from both the tables is deleted. There is no data present in department as well as no data present in employee. This is because there is a relation between department ID and ID column. The department ID references to the ID column. Probably you see the data from both the tables are deleted because both the tables matches that condition. From this, what we can say is relational integrity is maintained automatically when we use JSON duality views. You delete the data from the parent table, the respective data which is matching from the child table is also deleted. So these were the CRUD operations which we tested on JSON duality views. Now coming to the next part, how we can inspect duality views with the help of information schema in MySQL. In the recent addition of MySQL 9.7, we have some additional tables which are being added to the information schema. So let's start with first table, that is JSON duality views. This table helps us to view the permissions and the different types of views which are created and what are the permissions on that view. Basically, we are just passing here a table schema, that is JSON. So what it gives is what are the views present in the schema. So we have two views, department underscore DV, which is writable, department underscore RO, which is readable view. The root table name is department. And among this, only one view has write permissions, that is allow insert, allow update, allow delete. As the other view is created read only, it doesn't have any insert, update, delete permission. Now coming to the next table, JSON duality view column. This table helps us in mapping JSON keys to the actual columns of the table. So if you see, underscore ID is the key which is mapped with the ID column of department table. Department is the key which is mapped with the name column of the department table. It basically tells us the mapping between the keys and the actual columns of the tables. Now coming to the third table, which is JSON duality view links. What this table tells us is how are the tables linked to each other. Basically, if we have a relationship like one table is parent and one table is child, this views tells us the relationship between this two underlying table. Now, if you see, department table is parent table and child table is employee. Also, it tells us the parent ID column name and the child column name. So this is how we can inspect the duality views, or we can get the metadata of the duality views using information schema in MySQL 9.7. Now let's come to the final thing, which is limitations in JSON duality views. Let's come to the first limitation. Permissions are per nesting level. What this means is whenever you grant permissions, those permissions are per nesting level. If you see, we granted the permission insert, update, delete at each object level. That means at the root level as well as the child level. In case if you don't provide these permissions at any one of the level, that level goes into the read-only mode. Read-only mode in the sense you will not be able to perform any insert, update, delete operations on that particular level. Coming to the next limitation, what we see is locking isn't automatic. What this tells us, there is no concurrency protection unless you send the E tag explicitly. We have already sent this. We have already seen this case in the previous slide. If you don't provide the E tag when you update the data, MySQL gives you warning, but the data is changed. That means locking isn't automatic. To have the concurrency protection, you have to pass the E tag explicitly. Let us see what is the third limitation of this. Every key needs a real column. As you see, every key is mapped to the actual column of the table. So here, it doesn't support virtual or generated column. The column which the key maps should be the real column. And the last one is no caching for the view. So these views are not cached anywhere. Basically, when you get the read from the view, under the hood, the live queries are executed. So it is always recommended that you test it at scale before relying completely on it. So that's where the limitations of JSON duality views. So happy for any questions.
Yes, Sabash, awesome delivery. And this JSON Duality view in MySQL 9.7 is quite interesting. And that brings us to the end of our first segment on JSON Duality views. So before we move on to the second half of our webinar, to explore the Hypergraph Optimizer, we want to pause here for just a couple of minutes to take one or two questions from the audience, specifically on duality views. So attendees, please type your questions on JSON Duality Views in the chat section. Shahbaz will address those questions live. Yes, Shahbaz, we have a question from Dinesh Kumar. How do JSON Duality Views help ETL, ELT processes?
ETL and ELT processes. Yes. Basically, what happens is the application or the REST services expects the data in the JSON format, that is JSON document. But in the underlying table, the data is maintained in the relational format. So in case if you expect the data in the ETL or ELT in the JSON format, you can directly fetch the data from the views instead of relying on the relational tables. So you get it what is expected in the JSON document format. This is how you can use in the ELT processes.
Thank you, Dinesh Kumar, for your question, and Shahbaz for your answer. And we have one more question from Bala Murugan. JSON Duality Views is stored in memory or somewhere, or any benchmark for performance?
JSON duality views are not stored in memory. Those are generated at runtime, basically on demand. So that's similar to you running query manually. But the only change is you get it in the JSON document format. Under the hood, you are running the same query only. Only the change is the way it presents the data. When you run the same query, you get it in the normalized structure, okay, on the actual tables. But when you run this view, you get in a JSON document format. This is the only difference. Under the hood, the query you are running will be same only, and the performance or the impact also will be as the normal query only. There is no change in performance. So that is why it is always recommended that you test it at scale, because finally it is going to run the query live.
Thank you.
Okay, all right. So it looks like there are no questions in the chat right now, which means our audience is completely clear on JSON Duality Views in 9.7. So thank you everyone for those fantastic questions. And we will also have another dedicated Q&A session at the very end of the webinar. So please keep those questions coming in the chat. So for now, let's move on to the second half of our webinar, Hypergraph Optimizer. So over to you, Shahbaz.
Yes. So guys, in the second part of the webinar, we are going to cover Hypergraph Optimizer. This is again a smart query planner, which is being introduced in MySQL 9.7. So here's the agenda for the Hypergraph Optimizer, which we will be going through. Query processing unit. How does the query gets processed? Basically, we are going through the stages. Why a new optimizer? What it made for new optimizer to come into picture? What is Hypergraph Optimizer? We are going to see the difference between the classic versus Hypergraph Optimizer. Benchmarks which we have tested using Hypergraph Optimizer. How to enable the Hypergraph Optimizer, whether it might be at session level or global level or at query level, how to enable it, and most importantly, when to use it and when to skip it. So this is the agenda for the Hypergraph Optimizer. Let us start with the basics, how query processing unit works. Okay, what are the stages through which the query goes before execution? The first stage is parsing. This is the stage where your SQL syntax is validated. Second stage is resolve, where your column names and table names are accessed. Third stage is rewrite, where MySQL internally tries to rewrite the query for simplification. Fourth and important stage is optimize. Your classic and hypergraph optimizer lives here. This is the place where final plan for your query is built. And the fifth stage is execute, where you run the query and stream the rows. So this is a quick primer how the query gets processed. Now let us see why a new optimizer, basically what it made for a new optimizer to come into picture. So here we are going to basically see the shortcomings of the classic optimizer. Starting with the left deep chains only. So classic optimizer always go with the left deep chains only. It doesn't support the Bushy join. What this means is it cannot allow two independent join to work and merge the results. It always go with a single chain. The second shortcomings of classic optimizer is nested loop bias. What it means is it always prefer nested loop bias, even though when the using hash join can be more beneficial. Number 3 shortcomings of classic optimizer is handling order by. In classic optimizer, order by is an always afterthought. Basically, order by is considered at the end, whereas in Hypergraph Optimizer, order by is considered upfront. Now let's go to the fourth shortcoming of classic, greedy search on 8+ tables. What this means is when we have a large number of tables involved in this query, it goes for the guess plan or it goes with a fixed rule of thumb plan. It doesn't evaluate the plans and chooses the best. It just go on the guess method. And finally, no cost catching. So the catches for the evaluation plan when subjoins are involved is not catched. Every time it has to recalculate. So that was all the shortcomings of the classic. Now let us see what is Hypergraph Optimizer. So in Hypergraph, every table is considered as a node. So we have 4 tables A, B, C, D, which are considered as a node here. So the join conditions between these tables are called edges. So if you see there is join from A to B, B to D, A to C and C to D, all these are considered as edges. So whenever we are spanning across the 3+ tables, these edges are called hyper edges. That is the reason this is called hypergraph and not just as a graph, because it involves more than 3 tables and we are joining it via edges. This is all regarding the hypergraph. Now let us see some comparison between the classic and hypergraph optimizer. So before I move into the technical side, I want to give a real world picture. So if you see this, we have a classic and hypergraph optimizer. In this case, we have the warehouse and we have 4 stops A, B, C, D. So if you see, classic optimizer visits stops in a fixed order without checking the full map. So what it does is it starts from the warehouse, it goes to the stop A and then goes to the B, goes to the stop C and then finally goes to the D. You can already see this. This is not the shortest part, but still it goes in a fixed order because it has not checked the complete map. Whereas in Hypergraph Optimizer, if you see, it first sees all the stops on the map and picks the shortest one among them. So if you see, it starts from the warehouse, then it finds the 2 plans which are the shortest. One is direct to the stop D and one is along with the stop B and finally to D. Then finally it evaluates and chooses the shortest plan, that is from B to D. This is how Hypergraph Optimizer evaluates the plan and chooses the best one, whereas classic visits in a fixed order or classic goes with a fixed thumb rule. This is the difference between the hypergraph and classic optimizer, considering a real world analogy. Now let us go and see the difference on the technical side. We are differentiating classic and hypergraph based on the plan shape. As we already saw in the previous slide, the shortcomings of the classic where it always prefer the left deep chain. So if you see, we have the tables, order customers, order items, and products. So it continuously joins all the four tables. Okay. Here, the large intermediate results are carried through every chain. As it joins the data in single change, obviously the results are going to be increased. Basically, the rows it is scanning is going to be increased. And finally, it provides the filtered result. But if you see in the hypergraph, as it supports the bushy plan or bushy join, two intermediate tables can be joined and finally the results can be merged. So this helps in reducing the data before combining the results, which finally helps in execution of the query. Coming to the next difference, this is in terms of join algorithm. As we have already seen this also in the previous slide, this is another shortcoming of classic, where it always prefer nested loop join. Even when the hash join can be more beneficial, still it goes to the nested loop. But in case of hypergraph, it evaluates between the nested loop join and hash join and basically proceeds with the most cheaper one. That is, if hash join is going to be more beneficial, it goes with the hash join. Now coming to the third difference between classic and hypergraph, this is in terms of order by handling. How order by is handled in classic and how order by is handled in hypergraph. In the classic, it goes with the routine workflow. That is, it reads the data, it processes the data, and finally at the end, it sorts the result and it provides you the filtered result. That means in this case, the data sorted is always more than necessary. You sort a large amount of data. But if you see in the hypergraph, order by is considered upfront. Upfront in the sense when it is evaluating the plans, at that stage itself, the order by is considered. So if you see, it considers the ordering early, chooses more efficient plan. As the ordering has already completed, it has to process only fewer rows and returns the required rows. This is the major difference in handling order by in classic and hypergraph optimizer. Now coming to the last difference, that is cost catching. So let me give you a simple example here. So we have four tables A, B, C, and D, and we have the three candidate plans for this four table. Okay. If you see the three plans, we have the first plan in classic A, B, join C, and then join D. So the cost of join A and B is computed in the first plan. Now let's get to the second evaluation plan. In this also, the join A and B remain same, but the join order of C and D changes and it becomes as D and C. Here again, the cost of A and B is computed again. Now let's go to the third evaluation plan. A and B join C and D. So if you see, we have the A and B here again. So the cost of A and B is computed again. From this, what we can see is, even though the cost of A and B is computed in the first plan, still the classic computes this plan every time. Every time for if you have a multiple plans, it evaluates this cost for all the plans. Whereas in hypergraph, if you see the same joins, the cost is computed once, it is catched, and it is reused in the next evaluation plan. So in hypergraph, the cost catching recalculates repeatedly because the cost is calculated every time. And in the classic, and in the hypergraph, the cost is computed one and it reuses in the next evaluation plans. This is the major difference in terms of cost catching. So these were all the differences between the classic and hypergraph, which we more focused towards the which were basically more focused on the shortcomings of the classic. Now let us see how we can enable the hypergraph optimizer. So in MySQL 9.7, this is not enabled by default. We have to explicitly enable this. This can be enabled at session level. It can also be enabled at global level. And the best approach and the safest is it can be enabled at statement or query level as well. So before you directly enable this hypergraph optimizer by default, it is always recommended test your queries and see the results and then go it based on the queries session or the global level. Now that was more on the theoretical part. Now let's look at the actual benchmark numbers. So just to inform you, for every benchmark we have carried out, we have used the exact same data set and we have used exact same query. The only change what we have done in this benchmarks is changing the optimizer switch. We have switched the optimizer to classic. We have switched the optimizer to use hypergraph. So basically we have tested three scenarios. Okay. Each stressing a specific weakness of classic optimizer. So now in the benchmark one, we have stressed join algorithm choice. In the benchmark two, we have stressed order by handling. That is how the order by is handled in classic and hypergraph. And in the benchmark three, we have stressed plan shape. That is, if you see in the classic, it always preferred the left deep chains, whereas hypergraph has the option of bushy joins. So these are the benchmarks which we have carried out. Now let us see the actual benchmarks. Okay. First was with the algorithm choice. Okay, join basically. Nested loop versus hash join. So these are the tables, customer orders, order items, and products with the number of rows already highlighted. This is the query which we are joining the multiple tables and finally grouping it by city and the product name. So if you see the explain plan of the classic and compare it with the hypergraph, if you see the nested loop join is replaced by the hash join everywhere. Okay. Basically, classic preferred as nested loop join and hypergraph preferred hash join. So as it preferred the nested loop join, crossed grows with every row. That is, repetition is expensive. But in hypergraph, as it preferred hash join, the matches were made in the memory. So there were no repeated loop. You can see the timings also of the query execution. Preferring hash join, hypergraph optimizer could execute this query in 22.16 seconds, while classic plan, which preferred the nested loop join, executed the same query in 38.13 seconds. So basically, hypergraph was 42% faster than the classic in this case. So this is the benchmark one. Now let's proceed with the benchmark two. So in the benchmark two, what we are seeing is how the ordered by is handled. Late sort in classic versus early sort in hypergraph. So the number of rows and the tables are already highlighted. And finally, we go with the query. We are joining multiple tables and ordering it by order underscore date in descending order. And finally, limiting that to 50 records. So if you've seen the classic plan, it completes the joins first and finally last it prefers the sorting and then finally it limits the rows. Okay. Whereas in hypergraph, it sorts and limits early and then it takes the further processing of the query. So if you see, just by changing the how the order by is handled, order by is an upfront in hypergraph, whereas ordered by is an afterthought in classic plan. Just by changing how the order by is taken care, we see a huge difference in the query performance. Hypergraph could execute this query in 3.01 seconds, whereas classic plan took 2 minutes 24 seconds. So hypergraph could execute this 48 times faster than the classic. This is a huge win for the hypergraph. Just by changing the order by sequence, it was able to execute the query 48 times faster. Now let's go to the benchmark 3. Benchmark 3 is in terms of left deep chain versus bushy plan. As we already seen this in the shortcomings of classic. Classic always goes with the left deep chain, whereas hypergraph has an option of bushy joins, where it joins two independent tables and we can merge the results. So as expected, this is the query. And we have the number of rows in this tables and the query used is using multiple joins and then finally grouping it by city, product name, supplier name, and shipment status. So if you see, the classic plan joined all the tables in one long path, that is left deep chain. And there is no way to split the work here because it has to join all the tables and carry the intermediate results. But in the hypergraph, if you see, it splits the table into independent branches. That means two independent table can work together and finally that branches can be merged at the end. So hypergraph can have, in hypergraph, we can have two independent tables work together and finally merging. But in Classic, we don't have that. It has to go through a left deep chain, joining the table one by one, carrying the intermediate results. So in this case also, if you see the query execution time, the hypergraph could execute the query in 54.7 seconds, whereas the Classic plan took 2 minutes 19 seconds. Again, hypergraph was able to execute the query 61% faster than the Classic plan. So these were the three benchmarks which we tested based on the shortcomings of the Classic. Now let us go to the important state where we decide when we can use hypergraph and when we can skip it. So using hypergraph, usually when we have 4+ tables in the query, we can try going with the hypergraph optimizer. Number two, when there is a order by with limit. Basically, when we are sorting a large amount of rows, yes, we can give a try on the hypergraph in this case as well. And finally, when the queries are overlap, that is analytical and reporting queries, you can definitely try hypergraph for the complex joins. And in case where the Classic optimizer can be fine is simple lookups by primary key. Basically when we have only one table involved, there is a direct lookup with the primary key. There are no complex joins. In that case, you don't have to use hypergraph. The Classic optimizer can work here with no issues. Another important thing which I would like to recommend you is don't switch to hypergraph without testing. Always go with explain analyze, check the query performance, check the explain plan, and then finally you can change it to the hypergraph optimizer instead of Classic. So coming to the final key takeaways. So in JSON Duality Views, it works as both relational rows and JSON documents. Read and writes are possible to the JSON directly. We don't have to do any changes or coding at the application end. And e-tags help in preserving the concurrency control to prevent the lost updates. Whereas in hypergraph, it is again a smart query planner. So you can try this with when your query involves a complex joins and 4+ tables. It is great fit for analytical and reporting queries. And more importantly, it speeds up your queries with the heavy sorting. You can test your slowest query just by changing the optimizer switch to hypergraph optimizer on and get the things analyzed on your own. So that was all regarding the hypergraph optimizer. Also, we have a few more features which are being added in MySQL 9.7. So we will be covering those in our upcoming blogs and the next webinar. Thank you, and happy to take your any further questions.
Hey, Shahbaz, thank you so much for that flawless presentation and practical session. The session on JSON Duality Views and the Hypergraph Optimizer, right? It was incredibly valuable, and we truly appreciate your time and expertise today. So let's move on to Q&A now. To make this more interactive, the mic is open now. Audience can unmute yourself and ask your questions directly to Shahbaz. So when you ask your question, please introduce yourself and then ask your question.
I like to attend this session from your Mydbops LinkedIn page. I came here and I gained a lot of information about JSON, JSON Duality View and Hypergraph Optimizer.
Okay.
So my question is, how does Hypergraph Optimization relate to data warehousing?
Data warehousing. Okay. Finally, optimizer is the thing which works in the backend. Okay. In the data warehousing, probably we use the complex queries. Okay. Analytical or reporting queries. There is nothing change in the queries. The only changes in the hypergraph optimizer. That is the only changes. We are replacing the Classic optimizer with the hypergraph. There are no changes in the queries. There are nothing changes to be done in the application end as well. Only in the database end, you have to pass the optimizer switch along with that query. Or if you are sure all your queries can use hypergraph optimizer in a well-defined way, you can change it at global level and you can use that. There are nothing changes to be done in the application end. Basically, the queries which we use in database data warehousing or reporting queries. So definitely Hypergraph can be more beneficial when it comes to the data warehousing.
Thank you, sir.
Thank you, Dinesh, for your question. Thank you, Shahbaz. And anyone else? So you are free to unmute yourself and ask your question.
Yeah, Sebastian, thank you for the things. So I have a question. So while enabling Hypergraph Optimizer, so does it like utilize any memory or CPU process, any like extra additional resources it will use?
Yes, there is no adverse impact of enabling Hypergraph Optimizer. What it does is it just replaces your classic optimizer with just Hypergraph. So there is no adverse impact when you enable that.
Okay, so we can enable it globally and
No.
by using parameter level, or like we can directly enable from the
Yeah.
server without like bouncing the server.
Yeah, so we can enable it globally, but the most important thing which I already highlighted in the slide is you have to test your queries first. Okay, that depends on the type of the query. If Hypergraph is benefiting you, okay, in terms of the evaluation plans and the query execution time, definitely you can go with that. Also, this can be enabled at runtime, and this doesn't require a server reboot.
Okay. So it is available from 9.7. So before it is not there, right?
Yes, yes. So Hypergraph Optimizer is introduced since 9.7 only. Prior to that, we don't have that.
Okay. And for dual views also, like, is there any specifically can we use like similar kind of normal views? Any extra thing that we have in the dual view perspective?
Yes, normal views are not writable.
Yeah, right.
Yeah. So dual view are writable, more importantly.
So like like any permission level do we need to grant to the views?
Yes. So as I explained in the previous slides, we have three permissions through which we can do CRUD operations on the views. That is insert, update, delete. So that depends on you. If you just give all the permissions, that is insert, update, delete for both the nesting levels, then you can basically do all the CRUD operations. But if you limit it for any one of the level, you don't provide the right permissions, then that part of the level goes into the read-only mode. Basically, you will not be able to do any writes only to that nesting level. And for the level which you are providing the insert, update, delete permissions, you will be able to do any CRUD operations on that.
Okay, so like whenever we do migration, that time some tables are not exist or some deleted. So that time sometimes normal views we are getting the issues. The table is not present, unable to restore like that. So similar way, does any kind of stuff do we see in the dual views? Any background things happen?
No. Basically, JSON duality views also works based on the underlying tables only. So if you don't have tables, there is no any difference between the normal view and JSON duality view. Both the views fetch the data from the underlying tables only. So having tables is mandatory.
Yeah, okay. So that we need to check backend as like normal view.
Correct.
Yeah, okay.
Thank you, Shiva, for your question.
Yeah, thank you very much. Got it. Thank you very much, Shahbaz.
Thank you.
All right. We shall wrap up here to keep it on time. So that brings us to the end of our webinar. Before we go, I want to say a huge thank you to everyone in the community for joining us today. And just a quick reminder for the attendees, I will send the slide deck and the recording link to your email early next week. And please follow MyDBOps on LinkedIn for our weekly technical blogs and event updates. And if you need any help with your database, you can reach out to us at mydbops.com. And you can also share your experience with this webinar on LinkedIn. And thank you again, Shahbaz, for your time. And thank you all for being such an engaging audience today. We will see you at MyDBOps 53 webinar, and have a great evening, everyone. Thank you.
Thank you, everyone.